Hi all. In today's session, we are going to see Twitter sentiment analysis using CF and TF-IDF. You can download this dataset from Kaggle. As you can see it on the screen, there are many datasets for this Twitter sentiment analysis, and you can download it from Kaggle. And after downloading, you have to upload it using this way. The project begins by loading the dataset using the pandas library. The data set is stored in a CSV file named twitter_data.csv, contains valuable text samples along with their corresponding sentiment labels. This data serves as a foundation for training and evaluating the sentiment analysis model. Let me show you this data file. So this is our twitter_data.csv file. It has around 1000 data. Using this statement, the syntax, we are printing the unique values under sentiment column. Label encoding is applied to the sentiment labels. In many machine learning algorithms, including the ones used here, numerical values are preferred over text labels. This label encoder from the sklearn library, can you see it here? From sklearn, we are importing pre-processing, and under pre-processing, we are importing this label encoder. This label encoder from the sklearn library converts the categorical sentiment labels, that is positive, negative, and neutral, into numerical equivalents 0, 1, 2. This transformation is very important for the models to process the sentiment information during training. So these are the converted values 0, 1, 2, 3. We have 4 labels here. Then for text pre-processing and feature extraction, we have to ensure uniformity and optimal handling of text data. A series of pre-processing steps are implemented. I'll tell you one by one. Special characters and numbers are removed from the text. If you see here, let me open the Excel file. Special characters and numbers are removed from the text using regular expressions. I'll show you the regular expression also. So this is a syntax we are using for this task. Only alphabetical characters are retained, which is essential for analyzing language-based sentiment. All text is converted to lowercase using this line. So this eliminates the variability caused by capitalization and ensuring consistent treatment of words regardless of case. Then tokenization is carried out using the NLTK library, splits the sentences into individual words. This is also an important step for breaking down the text into its basic components for analysis. Then comes stemming. It is performed using the port stemmer. We have used it here. So using this line from nltk.stem, import port stemmer, we have imported this library from NLTK. It reduces words to their root form. This step helps in consolidating similar words, which is important for consistent sentiment analysis. And after this is the processed text. The processed text is then formed into a structured corpus. CV, that is count vectorization. Can you see it here? We have imported, yeah, here from scalar dot feature underscore extraction dot text import count vectorizer. This is used to convert the process text into numerical vectors. So this is a process text. To convert this into numerical vectors, we are using this. Count vectorization is a technique that creates a matrix where each row corresponds to a document or text sample, and each column corresponds to a unique code in the entire data set. The cells of the matrix contain the frequency of each word's occurrence in each document. This transformation allows the machine learning models to work with numerical data, enabling further analysis. And after that, we have printed the shape of X. Okay, so we are using this step also. And the result is a stored in X. And here we are printing the shape of X. And then we are printing the shape of Y test, Y train. This is just for your understanding. And after we are going to train, we are going to split our data set. The data set is divided into training and testing sets to facilitate model training and evaluation. This train underscore test underscore split off function is used for this purpose. The training set is used to teach the model to recognize patterns and relationships within the data, while the testing set serves to assess how well the trained model generalizes to new unseen data. And the model that we have used here is multinomial NB. I'll show you where we imported this. So this is the line from sklearn.neighbors import multinomial NB. We're going to use one more model also, that is random forest classifier. Okay. A multinomial neighbors classifier is selected as a model for sentiment analysis. This is a probabilistic algorithm that works well with text data. This class, multinomial, can you see? Multinomial NB of this class is from sklearn, and the classifier is trained on the training data using the fit-off method, that is this method. Once the classifier is trained, it is used to predict sentiment labels for the testing data using the predict-off function, that is this line. The accuracy score of the classifier is then calculated using the score-off method. So here we have got 0.965. The accuracy score reflects the proportion of correctly predicted sentiment labels out of all the labels in the testing set, providing a measure of how well the model performs. Then the second part is a TF-IDF vectorization. And for this, we are going to use random forest. The text data undergoes another feature extraction technique called TF-IDF, that is term frequency inverse document frequency vectorization. It actually assigns weights to words based on their importance within the entire data set. Words that occur frequently in a specific document but are rare across the entire data set receive higher weights. This data set is once again divided into training and testing sets. As you can see it here, it is once again divided into training and testing sets. A random forest classifier, that is this line, known for its ability to handle complex relationships in data, is selected for this step. This classifier is instantiated using this line. So we have to measure a specified number of estimators, that is the decision tree. It's then trained on the training data using the fit-off method. So here the n estimators is 20. So with the trained random forest classifier, sentiment labels are predicted for the testing data using this predictor method. The accuracy score of the random forest classifier is calculated. So here it is 0.905. This AI-driven sentiment analysis project combines data loading, pre-processing, feature extraction, model selection, training, and evaluation steps. So that's all for the session. Thank you.